Okay, we are now live, and it's time for this. So, right now I got my title screen. It's a work in progress. I'll move this chat window over here. Wait, hold on. Can I pop this out in a new window? Shit. Alright, yeah, that's fine. It's fine. Smush. No, unsmush chat. I'm sorry, I'm still setting up. Okay. There we go. Yo. Okay, so let me start the game with what I have right now. Nothing, alright. I'll check my script, because I don't know how... You know what? Screw it. I'm going to delete this. I'll go to the main scene, go to 3D. I don't know how to, I'm going to delete tile screen. Automatic settings. Make something new. Let's see here. Okay, you know what? Video time. It's video time, guys. We are going to watch a thingy. No, not my channel. What? No, I mean this. Okay, so, okay, here we go.
I'm gonna teach you how to make your own games. After this video you will be a pro. The number one lesson is, your game idea probably sucks. The faster
Okay, fuck you.
you let go of the GTA 6 in your mind, the faster you will learn. This will probably sound really harsh, but no matter how good you think your game idea is, it's probably bad. And listen, I'm not trashing on
Fuck you. Straight up, fuck you.
you, I'm just telling you how it is. I'm not gonna serve you bullshit. Lesson number 2 is, you cannot escape programming. Games are literally computer programs. You can use visual programming languages, but you cannot escape programming itself. And for me, programming is the best part anyway, so why would you run from it? Lesson number 3 is always go in with a plan. Never make the mistake of opening a game engine and trying to learn it without a goal. You're just gonna be overwhelmed by the amount of options and information that you need to take in. The first time you open a game engine, you should already have a game idea in mind, something very simple like a Mario clone or a Pong clone. Before we move on to lesson number 4, I want to give you a few tips for your first games. You need to make at least 3 very simple projects. You're only supposed to learn from them. These are not things you're going to release or show anybody, just learn. They all have to be very different from each other. For example, you can make a Pong clone and then a Super Mario clone because they are really different in gameplay terms. As a third option, you could probably make a top-down shooter or something you want to make. Here it's important to understand that your games are going to be really bad and that you're going to have a ton of difficulties. You can try to do things on your own, but if you feel too stressed, watch tutorials, man. Don't let your ego control you. Allow yourself to do hard things, just not in the hardest possible way, you know? Lesson number 4, avoid tutorial hell, please. You shouldn't really worry about this in the first 3 games that we were talking about earlier because you were just learning the very basics. But after that, it's time to be careful with tutorials that teach you an entire thing, like an entire game type or an entire game mechanic, because you could become dependent on those tutorials and never really learn how to make your own systems and your own types of games. As I said, you don't have to do things in the hardest possible way, so I still recommend you watch tutorials.
Give me an actual tutorial. Okay. Nice.
This project is from the ground up for absolute beginners, so we will start by installing my game engine of choice, Godot Engine. Find your way to godotengine.org and click Download Latest, which for me is version 4.1.
Is that chicken FNAF in the background?
Then click the blue download button to get a hold of the engine. It works on Windows, Linux, Mac, and more recently on mobile too. Once you have unzipped that download, open Godot and select New Project from the Project Manager window. In the project name text box, I will name the project Basic 3D Platformer. Click Create Folder and then Create and Edit. Now we are in the editor proper, I will take a moment to cover the key areas we will be interacting with. The top bar holds menu buttons on the left, 4 buttons for the main screens in the center, and playback controls on the right.
Chat, is this hype?
The main screen buttons determine what is in the middle of our display. By default, in 3D mode, this will be our viewport showing us the game world. On the left are 2 docks, the scene tree showing virtual objects in our game, and the file system for accessing resources like images, sound files, and the like. On the right is another dock containing the inspector. This is where we will configure our game objects. Now we are in the game engine proper, we can get our starting 3D scene set up. We need 3 things to be able to see our game world in action: a camera, a world environment, and a light source. Create a new 3D scene by selecting the 3D scene option from the scene tree dock. This node 3D is the root of our scene, and we can add more nodes as children of it. Click the plus icon at the top of the screen to create a new node, or use the shortcut Ctrl and A.
Okay.
Type Camera 3D into the search bar at the top of the Create New Node window, and click on the Camera 3D node from the list below and click the Create button to add this new Camera 3D to our scene.
Whoops, hold on.
This camera allows us to see the game world when we run the game, but at the moment there is nothing in it to display, so we need to add a world environment and a light. At the
There's music.
Camera 3D to our scene. This camera allows us to see the game world when we run the game, but at the moment there is nothing in it to display, so we need to add a world environment and a light. At the top of the viewport, there is a toolbar with buttons for previewing our game world. Select the button with 3 vertical dots. This opens a menu for adding preview environments. At the top of the viewport, there is a toolbar with buttons for previewing our game world. Select the button with 3 vertical dots. This opens a menu for adding preview environments to the scene. Click the Add Sun to Scene and Add Environment to Scene buttons to add the default world environment and directional light 3D to the scene. You can customize colors and light angles with the options in this menu. Now we can get our scene running in real time. In the top bar on the far right, you will see 6 buttons that are all playback controls. Click the Run Current Scene button, which looks like a play button on a clipboard.
All this stuff I need to add. World environment. Yep, that's very important. Okay, and also directional light 3D. Directional light 3D. Yeah, okay, let's preview it. Select current as main scene. Let's play it here. Okay. Alright, so it's not letting me do anything yet. Okay, so
Godot will then prompt you to save the scene with control and Sun Viewer. There is nothing in it. This camera allows us to see the game world when we run the game, but at the moment there is nothing in it to display, so we need to add a world environment and a light. At the top of the viewport, there is a toolbar with buttons for previewing our game world. Select the button with 3 vertical dots. This opens a menu for adding preview environments to the scene. Click the Add Sun to Scene and Add Environment to Scene buttons to add.
alright. Yeah, I don't know what you were trying to say there.
Add the default world environment and directional light 3D to the scene. You can customize colors and light angles with the options in this menu. Now we can get our scene running in real time. In the top bar on the far right, you will see 6 buttons that are all playback controls. Click the Run Current Scene button, which looks like a play button on a clipboard. Godot will then prompt you to save the scene if you haven't already. I will name the scene
Now I can see stuff.
level.scene in the file prompt at the bottom and click Save. A window will open with our game running, and this will look like the viewport in the Godot editor itself, just showing the procedural sky we added in our world environment as viewed from the perspective of this new camera. Now is a good time to add a floor to give us something to look at and get used to orienting objects like the camera. To act as a floor, we need to add a Mesh Instance 3D to our scene. When you add a node to the scene, it is added as a child of whatever node is selected in the scene tree. Left-click on the node 3D to select it. Selected nodes are highlighted with a pale blue rectangle. With the node 3D selected, open the Create New Node dialog. As you might be able to remember, we can either use the plus
Take that. Yeah. New node.
or we can use the shortcut Control and A. In the search bar, find and select Mesh Instance 3D, then click Create. This Mesh Instance 3D node is our essential tool for showing simple 3D shapes. In the scene tree on the left, you should see the mesh instance is now selected with the light blue highlight. If not, select the Mesh Instance 3D by left-clicking on it. When a node is selected in the scene tree, we can access their properties in the inspector on the right. In the inspector, the Mesh Instance 3D node has a mesh property, where we can select how it should look from a variety of primitive shapes, like box, sphere, and cylinder. To select a mesh for this light. If not, select the Mesh Instance 3D by left-clicking on it. When a node is selected in the scene tree, we can access their properties in the inspector on the right. In the inspector, the Mesh Instance 3D node has a mesh property, where we can select how it should look from a variety of primitive shapes, like box, sphere, and cylinder. To select a mesh for this Mesh Instance 3D, click on the word empty next to the word mesh. Then select New Plane Mesh from this list to create our floor mesh.
Okay.
This plane is then visible in the editor's viewport as a 2 meter by 2 meter grey square. The plane is only visible from above, as a plane mesh is a one-sided object. If you move the mouse over the viewport, you can control the view with a variety of gestures. Click and hold the middle mouse button and drag the mouse up, and your view will rotate down to a view below the floor, showing it is transparent from the other side. Click and hold the middle mouse button and drag the mouse down to rotate the view back up, and you can see the floor again. The floor is too small at the moment, so we're going to need to update its size in the inspector. The mesh property of the Mesh Instance 3D now holds a plane mesh object that we can customize. If you click on the picture of a plane, the object will expand and we can customize its properties in the inspector. Godot has objects we can expand like this, as not all meshes will have the same properties. This plane mesh only has a width and a height, but if we say had a box mesh, it would also have a depth property. We can set the floor's size with the mesh's size property. Set the size properties X and Y values to 10 meters by 10 meters. You will see the mesh updates in real time in the viewport.
I'm doing something.
While hovering the mouse over the viewport, you can scroll the mouse wheel up and down to zoom the camera in and out for a better view. Now we need to move our camera 3D node for a better view. If we run the scene as it is, we will not be able to see anything because the camera is inside the floor. If you ever quickly want to check what the camera 3D can see, select the camera in the scene tree and hit Ctrl P to toggle the camera preview. This will show what the camera can see directly in the viewport. You can also toggle this view with the preview check mark in the top left of the viewport. To update the camera's position and orientation, we can use the 3D Gizmo. This is a handy tool available directly in the viewport for whatever node we have selected in the scene tree. Select the camera 3D node in the scene tree so we can update it with the gizmo. The gizmo is the 3 arrows and circular arcs in green, blue and red in the viewport. The gizmo is centered on our camera, which is made visible as a small arrow on the gizmo by expect that previous rotation property in drop chain meter and what you create. Godot offers many powerful graphical options to control the appearance of what you create, and it is best to understand these settings early so you can fix graphical problems as you encounter them. In the top bar on the left, select the Project drop-down, and from that drop-down list, click on Project Settings. The Project Settings window holds a host of powerful options for your games, as well as a bunch of useful customizations. In the tree on the left, you will see a variety of tabs for options relating to your project. Under the Display drop-down, click on the Window button, and options relating to your game window will open on the right side of the page. Settings. I am using a 1920 by 1080 monitor, so to best fit, I'm going to set my viewport width and heights and in the bar on the control the appearance of The project settings window holds a to use reliable screen is
Here.
often important
Here, this part.
like feel to the sun drop slide. My guide on how to create a 3D platformer in Godot 4.1. This is all part of the free supplement in my course Godot for Beginners. If you head on over to itch, there's a link down there, you will be able to go ahead and download these 3 sections all in written form so that you can follow along with that if you find that a more helpful way of learning. Once that's all wrapped up, there are 7 more sections available covering a bunch of extra topics relevant to 3D platformers, such as transitioning between levels, making grid maps, particles, and the like, all available in my course Godot for Beginners, and I'm considering creating more video content like this to go ahead and cover those topics in the future. Anyway, I'll let you get back to the rest of the video. Okay, have fun. Now we have a simple level, we can focus on getting our player character up and running. We may want to add the player to a variety of levels like this one, so we will make the player its own scene. In the top bar on the left, click the Scene drop-down and select New Scene. In the new window in the scene tree, select the Other Node option. When you select the Other Node option, the Create New Node dialog opens and lets us select any node to be the root of our scene. It will make the player its own scene. In the top bar on the left, click the Scene drop-down and select New Scene. In the new window in the scene tree, select the Other Node option. When you select the Other Node option, the Create New Node dialog opens and lets us select any node to be the root of our scene. For our player character, 2 nodes are up for consideration: Rigid Body 3D and Character Body 3D.
Soft body.
I am
3D.
going to show you how to make a Rigid Body 3D player character. This is physics-based at the cost of less precise control than the kinematic counterpart. In the search bar, find Rigid Body 3D, select it, and click Create. Now we can see our Rigid Body 3D in the scene tree. Double-click on the node and rename it to Player, then hit Enter. When you create a body node in Godot, to make them interact with other nodes and the physics of the engine,
maybe do this.
I am going to show you how to make a Rigid Body 3D player character. This is physics-based at the cost of less precise control than the kinematic counterpart. In the search bar, find Rigid Body 3D, select it, and click Create. Now we can see our Rigid Body 3D in the scene tree. Double-click on the node and rename it to Player, then hit Enter. When you create a body node in Godot, to make them interact with other nodes and the physics of the engine, we need 2 things: a mesh, so we can see the body, and a collision shape 3D. Add a mesh instance 3D as a child of the Rigid Body 3D we named Player. This node is how we will see our player. With the mesh instance 3D selected in the scene tree, look to the inspector on the right. Click the Mesh property drop-down and select New Capsule Mesh from the list. When you have a mesh instance 3D, you often will want to create a matching collision shape. To help with this, there is a contextual mesh drop-down at the top of the viewport we can use to generate a collision shape 3D. With the mesh instance 3D selected, click the Mesh button at the top middle of the viewport. Then, from the drop-down, select Create Simplified Convex Collision Sibling. Now we have our collision sibling.
Okay, simplified convex.
Drop down, select Create Simplified Convex Collision Sibling. Now we have our collision shape, we can focus on setting up our rigid body 3D for use as a player character. Select the rigid body 3D player in the scene tree, and in the inspector, find the lock rotation property and enable it.
Okay. Okay. Open all of these.
Rigid bodies are often used in the tree, and in the inspector, find the lock rotation property and enable it. Rigid bodies are often used as physics objects, with great freedom of movement and rotation. We need to lock our player's rotation so the capsule does not tip over as our player walks around.
Well, I wouldn't mind tip over. I want to tip over
Godot
absolutely.
uses script files to give instructions to the objects in our games. We write these in the GD script language, a specialized lightweight scripting language. We will add a script to our player character that will listen to key presses and use those to move the player in the corresponding direction.
Okay.
Right-click on the rigid body 3D root of our scene, and from the drop-down menu, select the Attach Script option, which is an icon of a little scroll of paper and a green plus. This will open a contextual window for creating a script file. We do not need to customize any of these options, so just click Create.
Second.
This will change our main
Second.
screen for the first time. Instead of seeing the 3D viewport as usual, we can now see the script screen. You can swap back and forth between these screens by clicking on the 3D button or the script button in the middle of the top bar as you need them. Our script has a few lines that are important to us right now. The first lines of the script says extend, then the name of the node, in our case, extends rigid body 3D. This tells us the script is attached to a rigid body 3D node, and we can access all the properties and functions of a rigid body 3D in code. Two functions have been added to this script by default. The functions are defined with the keyword func, followed by their names and parentheses. We will be focusing on the process virtual function. Godot has a bunch of virtual functions. A virtual function is a kind of built-in function you can add for a specific task. They have a specific name and specific parameters. Process is a virtual function. It runs every frame, so usually 60 times per second. This makes it an effective way to update your game in real time. The delta parameter tells us how many seconds it has been since the last frame, which is necessary for making changes appear the same on different machines, no matter how fast the game is running. Functions use indentation to separate code into blocks. So the parse keyword is indented to show it is inside the process function. The parse keyword indicates we do not want to do anything in this function. You are not allowed to leave a function empty, so pass is often used as a placeholder. In the process function, we can listen to input from the user, and if the
I'm gonna delete this script. Yeah. Okay, so all right, so let's go.
forward button is pressed, move the player character forwards. Input
Okay, so action. Okay, I'm learning shit. I'm learning shit.
is a global script you can access from anywhere. UI up is an event for the
Huh? I don't want to watch that. Sounds dumb. But mom, I'm live streaming right now. You never said that.
up arrow key.
No.
If
Mom.
this up button is pressed, the get action strength function gives us a value of 1.0. Otherwise, it returns 0.0 and the player will not move. So now our variable input is either 1.0 if the up arrow is pressed, or 0.0 if it isn't. Apply central force is a function of the rigid body 3D itself. It lets us apply a force in a 3D direction. 3D directions are represented by the vector 3 object, and
Oh yeah, vector. That was bad.
vector 3
0.0 asterisk delta.
Dot forward gives us a vector 3 pointing forwards. The asterisk symbol means we are multiplying the velocity by the 1200.0 that comes after. This makes the force we apply larger, so the player will move further forwards when the button is pressed. We need to multiply the force by delta to avoid issues on machines with different frame rates. When the button is not pressed, multiplying the direction by 0.0 will give us no velocity.
What are we doing wrong? Whatever. Let's move on to the next line of code.
This force applies every frame, and combined with the mass of our rigid body 3D, gives us a forward velocity when the up arrow is held. To test this script, we need to save the scene. In the top bar, click the Scene drop-down and select Save Scene.
Save scene.
The Save Scene As prompt should automatically name the file what our root node is called, player.scene. Click Save.
Okay.
This player is now a scene we can see down in the scene tree. Double-click on level.scene in the scene tree to reopen that scene. Then, in the top bar, click the 3D main screen button to return our view to 3D. Now we can add the player we can see down in the scene tree.
There we go. We can add him to the world. Let me see. Let me see it in 3D. Where is Spy Guy? Where is he? Where is he? Oh my gosh, he's so tiny. He's so little. Okay, let's start that. Oh, whoa. I don't know what that is talking about.
This tells us the script is attached to a rigid body 3D node in the it a parameter data up, so you have as a kind of built-in setting some different setting off. Listen to for length function gives us a value of 1.0. Otherwise, it returns 0.0 and the player will not move. So now our variable input is either 1.0 if the up arrow is pressed, or 0.0 if it isn't. Apply central force is a function of the rigid body 3D itself. It lets us apply a force in a 3D direction. 3D directions are represented by the vector3 object, and vector3.forward gives us a vector3 pointing forwards. The asterisk symbol means we are multiplying the velocity by the 1200.0 that comes after. This makes the force we apply larger, so the player will move further forwards when the button is.
How do you get? You know what? ChatGPT can fix it. I think
Virtual functions.
says
A virtual function is a kind of built-in function you can add for a specific task. They have a specific name and specific parameters. Process is a virtual function. It runs every frame, so usually 60 times per second. This makes it an effective way to update your game in real time. The delta parameter tells us how many seconds it has been since the last frame,
Stream's
which is